And number 3, we're given the parametric equations of a plane. They're asking us a variety of things. We'll start part A, of course. By inspection, find the coordinates of a point. Well, the point is the number part that comes at the beginning of each parameter. So the point would be 0, 0, and negative 1. Okay, because there's no number in front of the x or the y part parameters. In part B, what are the direction vectors? So direction vector 1 comes from the parameter 1. So we'll call it letter M just to make it easy because it's the letters we're using in the question. The x part would be 2, the y part's negative 3, and the z part's also negative 3. N would be no direction for x, 5 for the y part, and negative 2 for the z part. Part C asks us what point corresponds to these parameters. So, let's write them down again. X equals 2m, y equals negative 3m plus 5n, and z equals negative 1 minus 3m minus 2n. Just taking our parameters from the beginning of the question, okay? But they're telling us that m has to be negative 1 and n equals negative 4. Well, if I know that, I can fill those things in, right? M is negative 1. Oh, so my x is negative 2. M is negative 1 and n is negative 4. So we'll get 3 minus 20, which is negative 17. And z is negative 1 minus 3 times negative 1 minus 2 times negative 4. If we figure all that out, we get negative 1 plus 3 plus 8, which is 10. Okay, there's part C done. Part D, what are the parametric values corresponding to the given point? So we're given the point 0, 15, and negative 7, which means x has to come out to 0. So this time I'm working the parameters, but now I know the other side. Right? So 0 equals 2m. 15 equals negative 3m plus 5n. Same parameters, just we're given the values for x, y, and z. Negative 17 equals negative 1 minus 3m minus 2n. So we should be able to solve all these. Well, if we solve this one, it comes up to 0. We can now use that one in here. Solve for n. So n will have to be 3. And use both of those to solve the last one. So we just figured out that m was 0 and n was 3. So basically at this point we're checking, right? Negative 1 minus 0 minus 6. Hey, I got the right answers. So do my little check there. It's kind of a handy thing. Okay, so for part E, using our answer for part D, explain why the point 0, 15, and negative 8 cannot be on this plane. Well, if I use x is 0 and y is 15, and I solve for parameter m and parameter n, okay, so using x equals 0 and y equals 15, oops, y equals 15, both m and n can be solved for. Okay. Once I know what m and n are, z will be given by, well, the equation z equals negative 1 minus 3m minus 2n, where m equals 0 and n equals 3. Well, every time I plug in these two parameters, which were solved using the x and y, z has to come out to negative 7, not negative 8. So that point can't possibly be on there because every time I solve it, it comes out to negative 7.